going to be graphing hyperbolas. Okay, the reason I know this example, x squared over 16 minus y squared over 4 equals 1 is a hyperbola, is because of that subtraction sign. So, but the start of it is going to be very similar to graphing an ellipse. First thing I need to do is identify what the center is. The center on this one is going to be 0, 0, because if I look at these two pieces, this x squared and that y squared, nothing is being added or subtracted to it. Therefore, it has no translation. So here is that 0, 0. Now, I'm going to look at the denominators to determine how far I should move to the left and right. The denominator on the x squared is 16, so that means I'm going to move the square root of 16, or 4, left and right from that center. 1, 2, 3, 4. 1, 2, 3, 4. The denominator on the y is 4, so I'm going to do the square root of 4 to move 2 up and down. 1, 2, 1, 2. Just like an ellipse. Now, here's where we're going to differ because, again, this is a hyperbola, not an ellipse. We're actually going to make a rectangle that goes through those 4 points. Okay, I like to call this the magic rectangle because it's going to determine the shape of my ellipse. I'm also going to make it dotted, and I'll make it blue too. Okay. All right. So that's my rectangle. Again, you can see where the ellipse would have formed on the inside. Next, I'm going to do the asymptotes of this graph. That's going to guide the curves of my hyperbola. Now, the asymptote starts at one corner of our rectangle and goes to the opposite corner. Okay. Now, we also want to extend it outside our magic rectangle because it will show the branches. Now, I'm going to do the other asymptote. Okay. And extend it outside the magic rectangle as well. Next thing, I have to determine whether this is a left-right hyperbola or an up-down hyperbola. Because I have x as my positive, that means I will cross the x-axis. So this is a left-right hyperbola. Okay. If it had been y squared as the positive and x squared as the negative, then it would be an up-down. So let me show you what a left-right hyperbola looks like. It's going to cross this x vertex, and then it's going to head towards that and head up that way. Cross at that one and head towards the asymptotes on each of them. And that is my left-right hyperbola for this. Now, I already wrote my center. I could also write the coordinates of our vertices. Our vertices are the points on the magic rectangle that the branches hit. And those vertices happen to be plus or minus 4, 0. I can also find what's called the transverse axis. The transverse axis is the distance between these two vertices. So I'm 4 on the left and 4 on the right, so a total of 8 units. I can also find what's called the conjugate axis. The conjugate axis is the other direction. It's the side where the branches are not existing. So the conjugate axis in this problem is 4 units. Last thing I can do at this point is write the equations of the asymptotes. Now, we're going to think back to our Algebra 1 and find the slope of this line. Well, we're rising 2 and running 4. That's from these guys, 2 and 4. Okay, rising 2, running 4. So this line is y equals 2/4 or 1/2 x. This line on the other diagonal has a very similar slope, but it's the opposite. So we would say y equals negative 1/2 x. And that is our first example for a left-right hyperbola. Try number 2 on your own. Here in example 3, we've got y squared over 4 minus x squared over 25 is equal to 1. So first thing is the center. Our center is at 0, 0. Okay. Then we want to know how far we're going to head. Square root of 4 is 2. Now, notice though, this 4 is with the y squared. So now, even though it was the first value, I'm going to head 2 up and down. Now, the one with the x is the square root of 25, which will be 5. Means I'm going to go 5 along my x. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Now I'm going to make my rectangle. Perfect. Okay. Now I'm going to add the asymptotes. Again, asymptotes go corner to corner. These are the lines the graph is going to approach but not cross. Shimmy that one down just a little bit. Now another one on the other side. Okay. Now, this problem is different than our first example because my y is the positive. Okay. Since I have a y squared minus x squared, okay, over numbers, that's going to make this an up-down hyperbola. An up-down hyperbola is going to be opening. Oh, what did that change color? Back. It's going to be opening up towards along the y-axis and to the bottom. Okay. Now I can find the same pieces of information. I have the center already. I can find my transverse axis length. Again, the transverse axis is between our vertices. I can find my vertices. My vertices here are 0, comma, plus or minus 2. My transverse axis is 4 units in total because it's 2 above and 2 below. My conjugate axis, that's the other direction. It's the one perpendicular to the transverse. That's going to be 10 units in total. Unlike an ellipse where the major axis is the longer and the minor axis is the shorter, we don't have the same rules for on a hyperbola. Transverse is just between our vertices, whether it's the longer distance or the shorter distance. Last thing we want to find is the equations of these asymptotes. I'm rising 2 and running 5. So we're going to say y equals 2/5 x and y equals negative 2/5 x. And that's all the pieces we asked for on this. Now try example 4 on your own.